Welcome to today's mini lecture. The topic of today's lecture is going to be neutralization reactions. What we're going to look at and what we've been looking at is acids and bases, their properties, characteristics, how to identify and name. Now we're going to start doing some application. We're going to look at what happens when an acid and a base are mixed together. Well, if you have an acid and a base, we know that the acid is going to have to start with an H and the base is going to end with an OH. So therefore, what ends up happening is I get a double displacement reaction, and the hydrogen from this one will trade places with the base part of this one, and you will end up getting H2O, and then the base part and the acid part will trade places and form a new compound, or not trade places, but form a new compound, and that will be a salt. So all of these are nothing more than positive and negative ions trading places in that double replacement reaction. So I've given an example up here on the very first one. It says I have hydrochloric acid plus sodium hydroxide, and it yields salt, and this is a common table salt, NaCl, plus HOH. And I wrote this as HOH so that you could see that that is my H2O, but it's being formed in a reaction that is a neutralization reaction. So if I look at this, the first thing I want to do is balance the reaction so I can just start teeter-tottering. I have one hydrogen, I have two hydrogens, I have two hydrogens, I have one chlorine, one Na, one oxygen, one oxygen. So it's actually balanced. I don't have to add any coefficients. So the next thing I want to do is I want to go through and write the net ionic reaction. And I always get people to go, what do you mean the net ionic reaction? Well, what we need to know is what is going to be the driving force? What causes this reaction to go to completion? And the driving force is going to be one of three things. Number one, it's a precipitant. That's what we've been learning those solubility rules for, so that we can identify the precipitant. So if I look back, and a precipitant just means it dissolves in water. NaCl definitely dissolves in water, and H2O is water, so that's not it. Number two is it's a gas. So NaCl, that's a salt, it's not a gas, and H2O, at room temperature, it's not a gas, that's not it. The third driving force is literally water itself, and bingo. I have water, and I'm going to put a little L there in its liquid form. So that becomes a driving force. You say, well, what does that mean? Well, if I go in later on and I start looking at equilibrium, start looking at kinetics, then the part of this equation that I am going to be looking at, and the math part of it, is going to be what is considered the driving force. So if I have H2O as my driving force, that's all I have to write. I leave off the rest of it. But on the other side over here, I do have to write the positive and negative ion that created that driving force. And in this case, and always with water, it's going to be a hydrogen ion and a hydroxide ion. That's our acid base part. So this is going to be my net ionic reaction. I always get some students to say, well, why do we need to be able to do this? Well, if I want to go through and I want to determine where equilibrium is going to take place or what affects the equilibrium, this is what I can use. It makes it a whole lot easier. All right, the next thing here is another equation, acid, because it starts with an H, base, ends with an OH. This is sulfuric acid, potassium hydroxide. So first thing I want to do is I want to balance the equation. So when I look over here, I have two hydrogens here. I have one sulfate, I have one potassium, and one oxygen. So I've got two potassiums here, one sulfate, two hydrogens, and one oxygen. So I can put a 2 right here. And when I put that 2 there, that gives me two potassiums. This is with all double replacement reactions, just that teeter-totter back and forth, two potassiums. I have two oxygens. I have one oxygen, so I'm going to have to put a 2 here. When I do that, that gives me 4 hydrogens. I've got 2 hydrogens plus 2 more hydrogens is 4, and it's balanced with a 1, 2, 1, a 1, 2, 1, 2 coefficients. So I balanced it. Now I'm going to go through and I'm going to look, and I can't remember if this is going to be a precipitant or not. So I'm going to use my solubility rules, and it says that all sulfates are always going to be insoluble with the exception of group 1 elements. My group 1 elements is the ones that are in that first column, our alkali metals, and that's going to be the lithium, sodium, potassium, and rubidium. So that is an exception to the solubility rule, so this is going to be soluble. Therefore, my driving force is going to be the water. This time, I'm going to bring down my water molecule, and I'll put 2 of those, and then, I'm just going to do 1 of them, and then I will, on this side, say, okay, I have a hydrogen plus an oxygen, an OH. Now, if I would have placed that 2 right there, then I would have had to have put a 2 here and a 2 here. So that would give me 2 hydrogen ions, 2 oxygen ions, 2 more hydrogen ions to be balanced with a 2, 2, 2. But we don't have to do that because they do reduce down. Because it was a 2, 2, 2, it's just straight up like this. All right, so what have we really covered in today's class? What is a neutralization reaction? Acid plus a base yielding a salt and water. What is a net ionic reaction? Net ionic reaction is going to be controlled by a driving force, and there are 3 driving forces. The first driving force is a gas, the second driving force is a precipitate, and the third driving force is water itself. So I hope that helps you, and I'm looking forward to seeing you in the next lecture.